Hello and welcome to another edition of Pre-Calculus, Section 2.2 Day 1 Notes. Hopefully you have the Day 1 note sheet that you got in class today. If you didn't, you can print it out from Moodle, but it'll make this notes go a lot quicker. Remember, you can always pause the video if I get to talking too fast. That happens sometimes. We're going to be talking about power functions. And I always think of He-Man and Masters of the Universe. I don't know if you had those growing up, but I have the power, and he had a big sword and all that. But this is a different kind of power. So we're going to be talking about power functions and variations. If you had a good algebra teacher, they taught you that y varies directly with x just means y equals k times x, where k is some number. Well, that's about the same for this. So power function, we'll get to the first definition, it's any function that can be written in the form f of x equals k times x to the a. And the big thing here is that k and a have to be non-zero constants. That just means they have to be some number other than 0. So if you have just a number like f of x equals 15, that wouldn't work because your degree on your x would be 0. So k and a have to be non-zero constants. That's a power function. The constant a is the power. That's the power on your x. K is called the constant of variation or the constant of proportion. We say that f of x varies as the 8th power of x, or f of x is proportional to the 8th power of x. That's all meaning the same thing. The other thing we have is monomial functions, and monomial functions, you know, mono is not just the kissing disease. Monomial means 1. So f of x equal k, or f of x equal k times x to the n, where k is a constant, that means it doesn't change, n is a positive integer. That's important. Integer means it's not a fraction, and positive, you know, it's bigger than 0. So it can't be a negative, can't be a fraction, can't be a decimal. It has to be a positive integer like 1, 2, 3. That's what a monomial function is. So let's get into some examples that'll help you with the activity tomorrow. This first one, determine whether the function is a power function given that c, g, k, and pi are constants. For those that are a power function, state the power and the constant of variation. It sounds like a lot of complicated stuff, but it's really easy if you remember constant is just a number that stays the same. So when we look at this first one, f of x equals 8x squared, you've got a constant. That constant is 8. The power is 2. That's a non-negative. So this is a power function. And the constant of variation is 8. That's called the constant of variation. The power that's on your variable, that's the power of the function, that's 2. So constant of variation would be 8 for this one, and the power is 2. This next one, number 2, is not a power function at all. The reason is that your power is not a constant. The power is x, and x is not a constant. It changes. It's a variable, meaning change. So number 2 is not a power function. Number 3 is a power function. You've got pi as your constant of variation, and you've got 2 as your power on your function. So number 3 is a yes. Let's go into the monomial functions next. Determine whether the function is a monomial function given that L and pi represent constants. For those that are monomial functions, state the degree. If you remember, the degree is the highest power on your variable, and the lead coefficient. For those that are not, explain why not. So if we look at these, monomial means one term. So this one right here, 4x to the negative 3. This one is not a monomial function. The reason being is the power is negative. Remember, the power has to be positive integer. Number 5, it is, because you could represent negative 4 as negative 4x to the 0 power. Anything to the 0 power is 1, so that's where they get the degree equals 0. Lead coefficient is negative 4. Again, you could represent that as negative 4x to the 0 if you wanted to. The last one is also a monomial function, and the degree is 3. That's the power on the variable. The lead coefficient, you can say it's 4/3 pi or 4 pi over 3, but that's the number that's in front. That's the lead coefficient. Okay, so that kind of gives you an idea of what power functions are and monomial functions are. This is using language and writing it in math ease. So the area A of an equilateral triangle varies directly. When you see that varies directly, immediately you think equals k times something as the square of the length s of its side. So this, what they're wanting you to do in this section is write the statement as a power function equation. Use k for the constant of variation if 1 is not given. In this case, 1 is not given. So we're going to represent that as a equals k times s squared. Remember, varies directly. If y varies directly with x, that's y equals kx. This one, it varies directly with the square of the length of s sides. Okay. Next one, it says write a sentence that expresses the relationship in the formula using the language of variation or proportion. You've got W equals mg, where W and m are the weight and mass of an object, and g is the constant acceleration due to gravity. So they're wanting you to say, okay, what's varying directly? When you see this g is the constant, that's how you know that W is varying directly with m, because m is multiplied by the g. So the weight W of an object varies directly with its mass m with a constant of variation g. That's how you would write it as something varying directly. There's more than one way to say that, but as long as you have W varies directly with m with a constant of variation g. G is gravity, gravity is a constant. All right, analyzing power functions. Their graphs look a little funky, and we're going to get more into the graphs tomorrow. But they say to state the power and constant of variation for the function, fourth root of x, and graph it. It also tells you in your book to say whether it's even or odd. So if we go to do this, the constant of variation, well, it's kind of hard to come up with. You need to express this as a power. So hopefully you remember when you take the fourth root, you could express that as a fractional exponent. So you've got x to the 1/4. This is a power function because you could have fractions in the power function. And you could also say this is 1 times x to the 1/4. There's your constant. The constant's out in front and the power is 1/4. So the power is 1/4 and the constant of variation is 1. So you can rewrite those just like that. To graph it, you can sketch it by making an XY chart and looking for perfect fourths, like the 16th. The fourth root of 16 is 2. The fourth root of 1 is 1. That gives you a couple to do. But if you graph it, this is what it looks like. Fourth root of 0 is 0. And then I've got 1, 1 as a point, and I've got 16, 2 as a point. And it kind of curves that way. So that's how you would graph it. The question is it even or odd? It's neither. Okay. This one, it says describe how to obtain the graph of a function f of x equals 3x cubed from the graph g of x equals x to the n with the same power n. In other words, you got 3x cubed. So they want you to say, how do you go from x cubed to 3x cubed? So if you remember your transformations, when you multiply something out in front, that's a stretch. So it's a vertical stretch of factor 3. So we obtain the graph by vertically stretching the graph by a factor of 3, and these are both odd functions. If you graph them, odd means like if 1, 1 is on the graph, so is -1, -1. If you change the sign of your x, the y sign changes. It also has point symmetry, where it rotates around itself. So there's an example of how to graph it, so you can sketch that on your graph. I believe that's it for this section. Thank you, and we will talk to you tomorrow. And by the way, put down those flaming hot Cheetos. Bye-bye.